Welcome to the Explainer. Today, we are diving into two really powerful, but honestly pretty misunderstood JavaScript data structures. If you care at all about how your code performs and how much memory it's using, you're definitely going to want to stick around for this. So let's just jump right in with a question that might hit a little close to home. Is your code leaking memory? And the surprising answer is yeah, probably. And it often happens in places you wouldn't expect, with everyday data structures just holding on to things for way too long. All right, first up, let's talk about what I call the memory leak trap. We're going to see exactly how a standard, totally normal map can accidentally cause some pretty big headaches. Okay, check out this classic scenario. We've got an object, let's call it John. We stick it in a map as a key. Then, a bit later, we decide we're done with it, so we set our John variable to null. Now, you'd think that's it, right? Object's gone. But nope, the map is still holding on to it with what we call a strong reference. It's basically shouting at the JavaScript engine, hey, don't touch this, I'm still using it. So poor John is trapped in memory forever. This is where our hero, WeakMap, enters the story. To get us out of this memory trap, we need a totally different kind of connection, a weak reference. And that's the whole idea behind WeakMap. So what on earth is a weak reference? Well, think of it this way. A strong reference is like a command. It's a must keep. But a weak reference, that's more like a suggestion. It tells the engine, hey, I'm pointing to this thing, but look, if nobody else with a strong reference cares about it anymore, go ahead, clean it up. I won't mind. And here you can see the difference side by side. On the left, with a regular map, our John object is stuck, even after we've moved on. But over on the right, with a weak map, as soon as our main reference is gone, poof, the garbage collector is free to sweep it away. The weak map doesn't stand in its way. The object and any data associated with it in a weak map just vanish automatically. Now, this is absolutely crucial. This is the golden rule, you could say. This whole automatic garbage collection magic only works if the keys in your weak map are objects. You can't use a string, you can't use a number. It has to be an object. That's because this whole system is designed to manage the lifecycle of objects specifically. So weak map sounds pretty awesome, right? But it's not a magic wand you can wave at every problem. It has a very specific set of powers and, just as important, some very deliberate limitations. Let's break those down. So what can you actually do with a weak map? Well, you get all the basics you'd expect. You can .set a key value pair, you can .get a value, .delete an entry, and check if something exists with .has. All that core stuff is there. But, and this is a big but, here's the trade-off. You can't loop over it. There's no .keys, no .values, not even a .size to see how many things are inside. And when you think about it, it makes perfect sense. How could you? The garbage collector could literally delete an item from the weak map at any second, even in the middle of your loop. It would be completely unreliable, so JavaScript just doesn't allow it. Okay, so knowing all that, where would you actually use this thing? Let's check out a couple of super common and really powerful ways you'll see weak map used in real world code. The number one use case is for storing extra data about an object that maybe your code doesn't own. So imagine your app has a user object, and your little piece of code wants to track, say, a visit count for that user. You just store it in a weak map. The second the main app is done with that user object and it becomes unreachable, your visit count data just evaporates right along with it. No memory leaks, no manual cleanup, it just works. Another huge win is for caching. We all know caching is great for performance, but it's also a classic way to create memory leaks. If you use a regular map for a cache, that cached result sticks around forever, clogging up memory unless you remember to go in and delete it. But with a weak map, the cache basically cleans itself. As soon as the object you cached the result for is no longer needed, its cached entry just disappears. It's a much smarter, self-managing cache. Alright, so that's WeakMap. Now let's meet its sibling, WeakSet. It works on the exact same principle of weak references, but it's designed for a slightly different job. So if WeakMap is for storing some data about an object, WeakSet is just for keeping track of the object itself. It's for answering simple yes or no questions, like, have I seen this object before? Think of it for tracking things, like whether a user has already visited your site in this session. Here's a perfect example. Let's say you have a list of messages, and you want to keep track of which ones the user has read. When they read a message, you just add that message object to your WeakSet. Later, if some other part of the app deletes that message from the main list, you don't have to do anything. The garbage collector sees it's gone and automatically removes it from your WeakSet too. Your read list stays perfectly in sync. So let's bring this all home. After everything we talked about, what's the one big idea you should really walk away with from this explainer? Here it is. The data in a weak map or weak set is always secondary data. It's extra information, metadata. Its existence should never be the only thing keeping an object alive. The main application decides when an object is done. These weak structures just let you attach extra info that gracefully goes along for the ride and disappears when it's supposed to. And that leaves us with one final thought for you. Now that you know how this all works, take a look at your own projects. Think about it. Where might there be an object just hiding out in a map somewhere, in a cache or lookup table, just sitting there eating up memory long after it was useful? Because a weak map might just be your new secret weapon.